Hello, hello, hello. We are back with Chapter 7, Collecting, Displaying, and Analyzing Data, focusing in on Lesson 3, Populations and Samples, and this is the guided practice. So we're going to look at these two questions right here, question 1 and question 2, and we're going to choose the letter of the sampling method that would better represent the whole population. So number 1, the whole population is Clinton School Cafeteria and their student satisfaction. So we're trying to find the student satisfaction for the Clinton School Cafeteria. A states that Mark surveys 40 students who are in his classes. 72% are satisfied with the food in the cafeteria. Choice B states Tammy surveys 65 students by randomly choosing names from a list of all students in the school. 85% are satisfied with the food in the cafeteria. So out of option A and option B, which sampling method will better represent the whole population? And if you chose B, you would be correct. Tammy surveys 65 students by randomly choosing names from a list of all students. So we have a random selection process, and it's a list of all the students that are a part of the whole entire population. So this is really the ideal circumstance for creating a survey. Whereas Mark surveyed 40 students, but they were only in his classes. So that doesn't necessarily represent the entire population of the school. Okay, let's go ahead and look at problem 2. The population for the problem two is predicted winner in election for mayor. Okay, so we're trying to predict a winner in an election for mayor. So option A says Harris telephones 100 randomly chosen voters. 54% plan to vote for Mayor Green. Option B says Julia asks 70 people whom she knows. 45% plan to vote for Mayor Green. Which sampling method will better represent the entire population? Is it A or is it B? What do you think? If you said option A, you are correct. Harris telephones 100 random, that's key, chosen voters. And that's really what makes it a better choice than Julia just asking people she knows. That's not going to be as random as they're probably most likely the people that Julia knows thinks more like her, and so that's going to be a biased sample versus Harris just randomly choosing 100 voters that are already registered voters. That's going to be a more accurate method for representing the whole population. Okay, let's move on to problem 3 and problem 4. For problems 3 and 4, tell whether each sample may be biased and then explain your answer. So number 3 says a town official surveys 50 people in a library to determine if town residents want the library expanded. Do you think this is biased or unbiased? If you think this is biased, you are completely right. This is totally biased. A town official surveys 50 people in a library to decide if town residents, who are the town residents? The town residents are everybody. They're not just the people in the library. So because you're asking the people who would benefit from the library, of course they're going to want the library expanded. So that doesn't really tell what all of the town residents would like, if that's somewhere they would like to spend their money. So this is a biased sample because the people are not randomly selected town residents. Okay, let's look at problem 4. It says a cable TV company randomly calls 200 customers and asks them if they are satisfied with their service. Is this sample biased or unbiased? What do you think? And if you said that this sample is not biased, you would be correct. This sample is not biased because it is a random sample. A random sample. All right, let's go on to the back page. So for problem 5, we're going to tell whether each sample may be biased and explain your answer. So problem 5 states, George surveys 15 students on the soccer team to learn whether middle school students want more money spent on school sports. So do you think this is biased or unbiased? Well, when I'm looking at this, I want to figure out, well, what is the population? The population, it wants to learn whether middle school students. Well, if you have 15 students on the soccer team, is that representative of all the middle school students? And the answer is no. This is completely biased. So the sample is biased because it does not have a random sample of middle school students. I mean, if you ask all of the students on the soccer team if they think that the school should spend more money on sports, they're on a sports team. Of course they're going to say yes. So that's not really a fair representation of the entire middle school students population. Okay, so let's go on to problem 6. Now, problem 6 is a different type of problem, and we're going to kind of work on this together. A factory, what it states is a factory produces 12,000 computers per week. That's a lot of computers. The manager of the factory claims that fewer than 50 defective computers are produced each week. So this is the claim, that fewer than 50 defective computers are produced each week. In a random sample, what we found was that 500 computers, out of 500 computers, it was a random sample, 2 were defective. So we need to figure out if the manager's claim is likely to be true with this information. And to do this, what we're going to do is we're going to set up a proportion to determine how many computers using the sample were defective if there's 12,000. So to do that, we are going to have the sample, so total number of sample, and that's going to be over the sample this is the sample information, so number of defective computers. Okay, so the number of defective computers in the sample over the total number of computers in the sample. And then, so this is dealing with the sample. This is going to be the population. So the total number of computers. And then this would be the total number of defective computers. So that's how we would set up our proportion. So what is the thing we don't know? Well, we don't know the total number of defective computers. So we're going to go ahead and let that equal x. So let x equal the total number of defective computers. Okay, and then we're just going to plug in the information into this proportion. So the sample number of defective computers would be 2. In the sample, there was 2 that were defective. So it's 2 over the total number in the sample was 500. That's going to equal the total number of defective computers. Well, we don't know that. We're trying to figure that out. And that's our variable. That's what x equals. Over the total number of computers altogether, which was 12,000. Okay, so we're just going to solve. We're going to figure out what x is. Okay, so to get x by itself, right now it's being divided by 12,000. So we're going to multiply both sides by 12,000. This is going to make it 12,000 over 1. These 12,000s cancel out and become 1, and 1 times x is just x. So now we have x by itself. I'm going to multiply these fractions. To do so, I'm going to simplify. I know when I'm cross-canceling that 100 goes into both of these. 100 goes into 500 5 times, and 100 goes into 12,000. That would be 120 times. Okay? Also, I know that 5 goes into 120 because it ends in a 0. So I'm just going to go off to the side and figure out what 120 divided by 5 is. So 5 doesn't go into 1, but it does go into 12 2 times. 2 times 5 is 10. If I take this away, 2 take away 0 is 2. I drop this 0 down. 5 goes into 24 times. So, yeah, 4 times 5 is 20. There's no remainder. Boom. So that means 5 goes into 5 one time. 5 goes into 24 times. And now I'm just going to multiply across. I can't reduce this anymore. So 24 times 2. 24 times 2. 2 times 4 is 8. 2 times 2 is 4, equals 48 over 1 times 1 is 1. So x equals, 48 over 1 is the same thing as 48. X equals 48. And that means that there was a total number of 48 defective computers. Defective computers. So this means, so we want to know if the manager's claim is likely to be true. So the manager of the factory claims that fewer than 50 defective computers are produced each week. So if we found out that there was a total of 48 defective computers because of this sample, is the manager's claim true? And we would say yes. The manager's claim is true. And there we have it. All right, and we will see you next time. Goodbye.